Welcome to day 29 notes, chemical equations. So, chemical equations. As you know, chemical equation consists of reactants, and there's an arrow, and products. Reactants react, products are produced. All right. The arrow is the yield, separates reactants from products. All right. That's what happens in the middle. We don't talk about that. We just have before and after picture so far right now. All right, so when we talk about reactants and products, we need to know what state of matter they are. So there are states, all right, states of matter, all right, state symbols, all right, and you guys know solid, liquid, and gas. Also, there's aqueous, which means in water. So it's dissolved in water. All right, it's still this like sugar, like sucrose or glucose, any sugar. Sugar in water is still sugar. It didn't change. Sodium chloride in water is still sodium chloride. It's just in water. All right, solid, of course, is an S, liquid is an L, and gas is a G. Aqueous is an AQ. So those are state symbols. Those are reactants or products. We're good to go there. Now, there are 5 classifications of reactions, which we'll do. First one is synthesis or combination. All right, you're making something. This would be like A plus B yielding AB. An actual example would be hydrogen gas, excuse me, plus oxygen gas yielding water. It's going to be a gas. Usually that happens. Now, right, things we can do when we talk about, like, that's an actual equation. So we didn't talk about this yet, but we can put stuff above and below this arrow, right? What goes there? What would be good things to put there? Well, for example, we can put a triangle. That means heat is required. We can put down here the solvent. So let's say it's not in water. So you use a different solvent. You can put that there. You can put the temperature down there that you need to do. You can put catalyst down there. All that can go on the arrow because it's not in a before and after. It's not a reactant. It's not a product. But it's needed to make the reaction happen. All right. So this one, obviously, hydrogen and oxygen burn to make water. You need a spark. All right. 2. The second one would be decomposition. That's the exact opposite of synthesis. All right. So baking soda is a good example. 2. Right. Add some heat to some baking soda and it decomposes into sodium carbonate. Plus water plus CO2 gas. There you go. There's decomposition. 3. Right, depending on your book, single replacement. Some books call it displacement. All right. And here, all right, we have A x plus B going to A plus B X. All right, that's very straightforward. A's with X and then B's with X. Good example. All right, um, CuSO4, copper 2 sulfate. Plus iron, giving you copper metal plus iron 2 sulfate. There's an example of a single replacement reaction. Sulfate went from being paired with copper to being paired with iron. 4. Double replacement or displacement. All right, and this is switching dance partners. AX plus BY going to AY plus BX. All right, do-si-do. Good example. Sodium chloride. Sodium chloride plus silver nitrate. Switch dance partners, you get sodium nitrate and silver chloride. So with this, I want you to point out, notice there's a state symbol change right here. It's solid for silver chloride. This is because a chemical reaction happened. All right, we've got to come back. That's important because we didn't talk about the evidence of a chemical reaction yet, and we're going to talk about that in 1 second. All right, so last one, last but not least, 5, neutralization, which is a double replacement, but there's no evidence of a chemical change. Acid, base, salt, water. Quick example. All right, HCl, which is an acid we used, plus NaOH, which is a base we used, produces NaCl plus H2. All right, so those are the 5 classes, or 5 classes of a reaction. Now, evidence of a change. What are some of the evidences of a chemical reaction? How do we know something's happening that's a chemical change and not a physical change? Because that's important. So, first one, big one, is heat. Heat change. Heat or light produced. Now it could get colder, but most of the time our reactions, we're talking about exothermic reactions, heat coming out, so it uses heat or light produced. 2, permanent color change. 3, gas formation. And 4, an insoluble product. Which we call a precipitate. All right. So if we look at these, all right, in Our first example of the synthesis reaction, when oxygen and hydrogen react, heat and light are produced. Very good, right? The decomposition, you have a gas form. Single replacement, you're going to have a color change because copper sulfate is blue and iron sulfate is not blue. Copper metal is copper color and iron is iron color. So they change colors. So there's color changes all over that one. Double replacement reaction, sodium chloride and silver nitrate. You actually make an insoluble solid right here, right? And it changes color and it's a solid. Neutralization, there is no evidence that this took place. HCl is clear and colorless, sodium hydroxide is clear and colorless, sodium chloride is clear and colorless, and water is clear and colorless. So it's all clear and colorless, so that's why it's its own class. So those are the 5 types of reactions we'll be dealing with.